Chapter 13, Part 7, Surface tension. Surface tension is caused by a molecular attraction. In the figure shown that surface of the liquid is the interface between two media, liquid underneath and wall and air outside. Beneath the surface, which means in the liquid, each molecule is attracted in every direction by neighboring molecules, make the net force nearly zero in each one of them. On the other side, a molecule on the surface of a liquid is pulled only by neighbors on each side, which means that from air as well as from the liquid. It will be pulled downward from below because of the liquid, and there is no pull upward because the air has no attraction. This molecular attraction tends to pull the molecule from the surface into the liquid, which will cause surface tension. There is some factor affecting surface tension. First one, what is the type of liquid we used? Water has a greater surface tension than oil, for example. So it has different surface tension from oil. What is mixed with the liquid? Soapy water has lower surface tension than water without soup because of the mixed material. Temperature of the liquid. The molecule in a hot liquid will have higher energy and are not bound tightly as in a cooler liquid. This is all factor affecting the surface tension. Let us have an example. The contractive tendency of the surface of the liquid is mainly due to the surface tension. The first example, when we bend a wire and lower it in the water and then try to raise it, the spring, as shown in the figure, will stretch. Why? Because of the surface tension, the resistance of the surface tension. Example number 2. When the brush is taken out of the water, the hairs are held together by a force of surface tension. Other example, drops of any kind are spherical. This is because their surfaces tend to contract and force each drop into a shape having the least surface area for a given volume, which is the sphere. Bubbles are spherical for the same reason, surface tension. Capillarity. The rise of liquid in a fine, hollow tube or in a narrow space is called capillarity. In the figure shown, we have an adhesion force between molecule of the glass and water molecule, which draw the film of water into the tube as shown in figure A. But surface tension causes the film on the surface to contract. This raises the liquid from below to rise into the tube. When the force of the surface tension balances out the weight of the liquid will stop rising, as shown in figure C. The height of rise in the capillarity will depend upon the weight of the liquid and the narrowness of the tube radius. The lighter the liquid from the dense point of view, the higher the capillary rises. The narrower the tube, less radius, the higher the capillary rise. This photo shows the capillary tube in action. If you plan to go for holiday, you can keep your plant in your room alive by using the capillary phenomena. The capillary will feed the plants by water through times according to the capillary tube principle.